Okay, this is day 7 of the distance learning packet math section. So just like yesterday, we have a new topic. We're moving into the geometry section. So this is all stuff that we would have covered if we would still have school. So again, it's new. So it will seem confusing at first. So this is just showing different types of angle relationships. So the idea is we have two parallel lines, and you can see that these two lines are parallel, okay? And then if we draw any line across those two, it's called a transversal. So it can be any way we want. It could be like this, it could be like this, it could be at any angle. It's called a transversal. So we're going to look at the relationship between the angles made by those three lines. So like we have an angle here, we have an angle here, we have one here, here. So there's 4 at each intersection. And then how does this angle compare to this one? Okay, so there's some really cool things that happen when we draw lines like this. And you'll see that in these next few pages. So the names, all new vocabulary. Again, you're probably not going to remember much of it for next year, but you will review this again in geometry, and you will actually go through and prove some of the things that we're going to learn here. So thinking back to our transformations and the idea of congruence, or exactly the same, you can use your tracing paper to kind of prove that these angles are equal. So for example, corresponding angles. Okay, so if you took your tracing paper and you trace these two lines that make the angle, and then you move that, if you move that down to this angle, you see it lines up perfectly. So those are the same angle measurement. So those are congruent angles. Okay, same for alternate interior angles. So if you were to trace this, and you would line it up here, but you would have to rotate. So you'd have to turn your paper, and then you would see that it lines up perfectly. So those are also congruent angles. Alternate exterior, okay, this one. And again, you could trace it and rotate, turn your page, and it would line up perfectly with that one. Okay, supplementary angles. Okay, that's something you learned already, and that is when two angles or more make up 180 degrees. So if we take this angle plus this one, that would add to 180 degrees. So those are supplementary angles. Remember, the other one that we've learned is complementary, and that's when two angles add to make 90 degrees. Okay, so they're not the same angle measurement, but they add to make either 90 or 180, depending on if it's complementary or supplementary. Okay, now vertical angles. These ones are going to be exactly the same. So if you took this angle and then you flipped your paper over, or you could rotate, it would make this angle. So those are the same measurement. Okay, and then consecutive interior. We don't really go into that one very much, but basically this angle and this angle, it's the same as this situation. It's just the angles are not touching each other. So those are also, if we add those together, they would make, their sum would be 180 degrees. Okay. Let's see what we can do here. So we have some information about these lines. So we have the two lines that are parallel, L. Well, it should have an L there. So L and M. So these two lines are parallel. Okay, so sometimes there's a little like solid triangle drawn on them, just to show it's like a symbol that means they're parallel. And then the angle measure of PAX. So this is also new, okay? These three letters, like what does that mean? So just like in the triangle and the transformations, the order does matter. And to know the vertice of the angle, we look at the middle letter. So that's A here. So this angle. And then we draw angles, or we show angles with a little arc, okay, a little curved line right there. So that's the angle we're looking for. Okay, and then that one is 31 degrees. So this is 31 degrees. And the measurement of PBY, so that's this one. I'm going to use two arcs because it's a different measurement. Okay, if there's two angles that have the same number of arcs, it means the measurements are the same. So those are not the same. So we're going to show them with two different numbers of arcs. Okay, so what else do we have? What is the measure of angle APB? So this here. So that's the angle that we're trying to figure out. This problem is definitely one that it would be one that we would find at the very end of our unit on parallel lines and transversals. So it's a very in-depth problem, and I wouldn't expect anybody to really have this mastered. Even if we did have class, like this is a pretty complex problem. And you could, if you had a protractor, you could, use it and measure these actual angles. Now, sometimes they're not drawn to scale, so that's kind of a problem. But you could use it to help you measure these angles. So there's other ways. All right, so let's see if we can break this down. So based off of this information, so we know that some of these angles are equal, okay? So it kind of looks like this is a 90-degree angle, but you cannot assume that. We do not know that. So we cannot make that assumption. So here's what I'm going to do. I'm going to draw a third line, okay, from P, and I want it to be parallel as well. Okay, so here's another parallel line. So L, M, and this new line are all parallel. Okay, so let's just kind of ignore this big angle for now. So I'm going to focus on these smaller angles that I just made by drawing that third parallel line. And we're just drawing a line, okay? It's parallel. It's okay. We can do this. So here's a new angle, okay? And if we go back to this page, if we take a look right here, alternate interior angles are the same. Okay, so alternate interior, so it looks like these two. Okay, so those two angles are the same. So this must be 31 degrees. Okay, and these are, because we always need to justify. So I'm just going to, it doesn't say to do that, but these are alternate interior angles. And they are congruent. They're the same measurement. So those are both 31 degrees. Okay? And then we look below that line, and so just kind of ignoring everything above it. So now we have these two angles, so this one, and those are also the same as each other because of the same reason. So those are alternate interior. So think about it. Interior means inside of those parallel lines. Alternate means on the opposite side of this transversal here. Okay, they're on opposite sides, and they're inside of the parallels. So those are also alternate Oops. Alternate interior angles. Okay, and then in class, we would have had to write the reason. Okay, so why are these the same? And it's basically just telling me what type of angles they are. Okay, so now we can figure out the larger angle that we were looking for, which is this all the way from this line all the way over to here. So if we were to think about, okay, if I set up to measure from here all the way out to here, I would have to have 31 degrees and then another 54. So I'm going to add those angles together. So that angle, and we thought, right, didn't we say it kind of looks like a right angle, which is 90 degrees, so it actually turned out to be 85. So it was drawn fairly accurately. So angle, here's another symbol. This whole section is full of new vocabulary and new symbols. So we have a lowercase m for the measure of angle APB equals 85 degrees. So the measure of angle APB equals 85. So a lot of abbreviations for this. We don't have to write out a lot of stuff. So that little bitty m, this means the measure. So if we actually measured it. Okay, again, if we had a protractor, we could measure it, and that's what we would get, 85 degrees. All right, so let's continue. Okay, so here we are moving into yet something else in this section, and it is triangles. So any triangle, so remember we did right triangles, we used Pythagorean theorem to look at the side lengths, but this time it's any triangle. It doesn't matter if it's a right triangle or not, but any triangle has something the same about the angles. So here's a triangle. So if we add this angle plus this angle plus this angle, they would all add up always to 180 degrees. And again, in class, I would actually do a proof to show you, a visual proof to show you that this is true. So remember, 180 degrees is a straight line. And you can actually do this on a piece of paper. You could just take any sheet of paper, and what I would do is I would just take my scissors and just cut a corner off. Okay, so now you have a triangle. It's a right triangle, it's fine. Okay, you have a triangle, and then tear the corners off. Just remember to maybe put a dot in the corner so you remember which is the corner when you tear it, and just tear it off, and then on the edge of the paper, okay, along here, you could line up those corners. So you get one chunk of paper like this, another chunk of paper like this, and then another chunk of paper like this. And they would all line up and add to make this angle, which is a straight angle, which is 180 degrees. Okay, so that's kind of like a visual proof. All right, so anyway, a lot of the stuff you learn in 8th grade, you will have to prove using mathematical terminology and real proofs in geometry class in high school, which is going to be next year for most of you. Okay, so we need to figure out the missing angle. So again, all we need to know is that we add these angles up and it will give us 180 degrees. So just add these up. Number 1, 80 plus 40 plus x is the angle we do not know, equals 180. Okay, so we just combine like terms. It's just like solving an equation. So 80 and 40 is 120 plus x equals 180. Subtract 120 on both sides. So I get x equals 60. Okay, and then just, do this either in your head or on a calculator. Just make sure you try it with the original problem here. So if I take 80 and 40 and 60, and I add those up, will I get 180 degrees? So 40 and 60, that's 100 plus 80, 180. So it works. So always check your work. Okay, so the next section, there are fancy ways to think of this, but I try to keep you guys from memorizing more than you have to. So we want to know the angle outside of the triangle. So there is like a rule for this, but it doesn't really matter because we know that if we add the angles inside the triangle, it will add up to 180. So if I can find this angle, then I know that these two angles are supplementary, so they also add up to 180. And I can figure out this one. So I'm going to do what I just did, 63 plus 86 plus, I don't know, it doesn't matter. We don't need that. That's not our answer, so don't put x. We're just going to find that out so that we can find x with it. Okay, so 63 and 86. 63 plus 86 is 149 plus some number equals 180. So then we subtract 149 on both sides. So this angle inside the triangle is 31 degrees. So this is 31 degrees. Now we can find x. So 31 plus x equals 180. So I subtract, and I get x equals 149. So after you do this a few times, you will see that there is a shortcut, but I'm not going to tell you. All right, so the rest you can do. All right, the last part. This time we don't have just a simple problem. So this is basically like a rule of 4, a little bit different, but let's see what we can do. So it says to write a function, to write an equation for this situation. So a rental company charges $45 a day to rent a car, as well as a one-time $25 fee for the car's navigation system. So in 8th grade, we're always dealing with lines. So we always start off with y equals mx plus b. Okay, so we have 2 pieces of information here. And we need 2 numbers for our equation. So we need our slope, which is our rate. So here's our keyword per day. So this is slope. And then one time, that's a very good keyword for b, which is the y-intercept or the initial value or that one-time charge. Okay, so we have our information and we can write our equation. So y equals 45x plus 25. Okay, and remember we need to explain what these things mean. So x is $45 per day, so this is the days. And then y would be the cost. All right, and then graphing it, you've done lots of practice graphing, especially on the previous packet and in class, so I'm not going to do that. You might need to make a table if that helps, but you don't have to. You can start off with just the y-intercept and then use the rise over run after that. But if you have a table, it kind of gives you an idea of what numbers to put in here because there's no numbers and it's not going to be just 1, 2, 3, 4. Those numbers are too big to fit on the graph if you use those. The top right says solve. It doesn't give us a question to solve, but a question could be, how much would a 7-day rental cost? 7-day rental cost, right? So 7 days, use the same equation, y equals 45, but x is days, and we know it's 7. Okay, and then we just multiply 45 times 7. We get 315, and then we have to add the $25 for the navigation, and we get $340, and that's for 7 days of renting that car. So you can put anything, any number of days. You could do a month, you could do a year, okay, whatever. Okay, and that's it for